Good evening.
Good evening, Professor. How are you?
Okay. Yasso, you're here. Shambria, you're here as well. Valentina is here.
Professor, is there an easier way to access the exams? Because I don't know if it's because I'm challenged or what, but it takes me many tries and I get to the test exhausted already by the process.
It shouldn't be taking many tries. You should just have to click the exam one time. So you would have to contact the help desk with something like
Okay.
that. And then just, because that sounds like more some sort of computer issue. Does that make sense?
Well, I guess, yeah.
Then it's hard
It's just the
for,
way that it's set up. The password does not always populate onto the exam in person. So, in my experience, I had to log in, log out again, try again until at a certain point it just clicks in. And it's a process to go with the picture, with the scanning and this and that. So I don't
I
know if
haven't
other people
heard.
experience that too.
Well, every single online class in the whole school uses it, so
Okay.
not much that can be done really anyway.
Okay.
But that's not, so what I would do is I would see if maybe the help desk could help with a little bit with some of the computer setup, because it sounds like something to do with your browser actually. Okay.
Okay.
All right, so who else is here? Because I haven't heard of somebody saying that there's like an issue with the program or anything like that.
I have a question.
Yeah.
So how do we access the activities like misleading graph? I don't know how to access those, and I was asking other people and they said they didn't know how to either.
Well, you don't really have to do them, so they're not really available necessarily for access.
Okay, so they're just there?
I mean, I can show you how to access them, but that's not something that's really part of your grade or anything like that. So
Oh, so there's no grade for it?
no, the only thing you have to do is the stuff that's on my math lab.
Oh, okay. Thank you so much, sir.
Okay.
Professor, I just have one question. Can we use the calculator like the one in the syllabus on the test? It's like as long as we have it on our lap with like the whiteboard.
You should really not need it. You should just use the one that's provided on the actual
Okay.
honor lock testing. And I did respond to your email with that, I think, also previously. Did you get the email back?
I think I saw it right when I logged in, but I didn't get a chance to read it.
Okay. I'm just trying to find one thing because doesn't seem like it's very strange. All right, whatever. I don't see the notes for one of these things here. They don't seem like they made one. Sorry, let me just copy this over to this other thing real quick. D1, D2. 3. D5. Let's check one more time. A3, A4, B2, 3, 4, C1, C2, 3, 4, D1, 2, 3, 5. Yeah. Somebody forgot to do this. All right, it doesn't matter anyway. All right, so we were, I believe, we had finished all this area and volume thing, or excuse me, perimeter area and circumference, and now we were talking about volume and surface area. Right. I believe we started talking about volume a little bit, but we didn't necessarily finish. Right. Space figures occupy three-dimensional space and have both volume and surface area. The volume of space figure is the measure of its capacity or how much liquid it would be able to hold. The surface area is the total area that would be covered if the space were peeled and the peel laid flat. Another way to say it is like how much wrapping paper you would need to kind of cover the whole thing. All right. So he says there's three basic types of space figures, the figures which have the same two-dimensional shape on opposite sides, like a box, cube, right cylinder, prisms, etc. For these types of figures, the volume is found by multiplying the area of the two-dimensional shape by the height. So like if we have a box right here, I think we briefly mentioned this last time, but I don't really remember. Then I would be able to break this thing down into like a bunch of unit cubes here, where each one of these things is 1 unit by 1 unit by 1 unit. So that means the volume inside of here, we would say is 1 cubic unit, or we would say it's 1 unit cubed. And then I would have to count how many of these cubes we would be able to kind of fit into this thing. So then on this side, I'm saying there's approximately, let's say 6 of them. And then here, let's say there's 3. So that means there would be like 18 on this bottom base. Then if I started saying how high it was, so then let's say there was 1 cube here, 1 cube there, 1 cube there. It's sort of like each one of these things, there would be 18 here, there'd be another 18 there. And each level would more or less have 18 associated with it. So then if we multiplied by however many there would be in the height, we should be able to figure out what the total volume would be. So that's why they say the volume of one of these right rectangular prisms, this is called a rectangular prism, would be just length times width times height. Does that make sense? Guys?
Yeah.
Another way to think about it though is like almost, so like all three of these here, we could think of them all being with this formula. Volume is equal to base times height. So this means B is the area of the base. And then H is the height. So all we would have to do is the base area times the height, and that should give us the overall volume of the thing. Now, in this case, the base here has area S squared and the height is S. So therefore we get S cubed. In this case, the base area is length times width, and then there's the height. So we get length times width times height. What's the area of a circle?
360 degrees.
No.
Radius squared?
Square. What is it?
Radius squared.
Nope.
Is it pi radius squared?
Pi r squared is correct. The area of a circle is pi r squared. So then we multiply that times the height, and that's where we get this formula. Because now it's like they're stacking these circles now. Does that make sense? Does that make sense, guys?
I understand that.
So all you really remember is that the volume is going to be base times height for the first three here. This one is length times width times height. This one is S times S times the height, but the S is the height also. This one is pi r squared times the height. Does that make sense?
Yes.
All right, so now they start discussing surface area. So let's say we have a right rectangular prism again. Let's say this is L, this is W, and this is H. Now there's a front, if I said to you now, how much would the surface area be? That means like how much wrapping paper would I need to cover this, but exactly the amount. So there's two purple things here. I would have to cover them. This one on this left side, this one on the right side, I would have to cover those. The thing on the top and the thing on the bottom, I would have to cover those. Does that make sense? The one on the front facing face and the back facing face, the ones that are sort of shaded right now, what would the area of those be?
Length times width times height.
Nope. Just these two purple things. Length times width times height also can't be an area because you just told me three things. Three things would mean it's going to be a volume. Does that make sense?
Yes.
It's length times width.
The length and the height,
Not length times width. What did you say? Sorry.
length,
Lisa?
length times height.
Length times height is correct. So each of these two, what do you call it? Rectangles here have dimensions L by H. Does that make sense, Thomas?
Yeah.
So then the surface area in this case for just those two purple parts should be 2 times L times H. Does that make sense?
Right.
All right,
Is
so
that
now
it's a
two
cube?
times- 2 just because there's 2 of them, because you need
Yeah.
like that L times H amount of wrapping paper to cover one of them, and then you would need L times H for the other one, so it's 2 times that. Does that make sense?
Okay. Yeah. Not squared. Okay.
Okay.
Dominique, you understand?
Yeah, I think so. You said because it has 2 sides of each, right?
Yeah, it's like you got one rectangle over here and it's H by L, right? So then the area of this one is HL. Does that make sense? Or LH, whatever you want to call it. Does that make sense?
Yeah, it does.
But then there's another one. So that one's going to be LH also. So it's going to be L times H plus L times H. So that's 2 L times H's. Does that make sense?
Yeah, it does. When you put it that way. Thanks.
No problem. All right, so then now I got to count up some more of this stuff because we haven't really finished counting all of it, I guess. So let's do these. Sometimes these are referred to as like lateral faces. Lateral just really means like on the side. All right. What would the area of those guys be?
Width times height.
Width times height, but then there's 2 of them again. So we're gonna write
Yes.
2 WHs. Does that make sense? Does that make sense, guys?
Yes.
Yeah.
All right, and then now there's the last stuff to worry about, the top, I guess, and the bottom. What are the areas of those guys?
Oh, wouldn't it be the same, the length times the height as well?
No.
Width and length.
Because like this
Oh.
part is L, that part's W. Does that make sense?
Yeah, gotcha. Yes.
All right, so then this is the formula. Now, this is not that great of a formula. Like, it's kind of confusing. Does that make sense what I'm saying?
Yep.
Like, it's not really helping me that much. Like, I'm pretty sure that you know how to find the area of each of these things. I would just find the area of each one of them and then add it all up. I wouldn't really use the
Right.
formula.
That's what I used to do too. This is almost like cubing it, but without cubing.
Sort of, but the thing is that like if I don't already know like how to do it, I don't really think this formula is necessarily going to be the thing that's going to help that person all the time. Does that make sense? Because I don't even know if they're going to really understand what the L and the H and the W and the H and the L and the W means in this case. Does that make sense?
Right.
But if we do it with some numbers, which we'll do in a second, hopefully there's one right here that we can just do real quick. So this one, all right? Like if I was going to do this question, okay, surface area. So we want to find the surface area in this case. I would just be like, well, there's this guy in the front and there's one like in the back. So then this is 6 by 3. Therefore, it's 6 inches times 3 inches, which would give you 18 inches squared. Well, we got 2 of those. So that would be, I guess, 36 inches squared. And then I would take the one on the side. And I would say this one looks like it's 5 by 3. So this is 2 times 5 inches by 3 inches, which is 2 times 15 inches squared, which is 30 inches squared. And then I would just say there's 2 from the top and the bottom. And I don't need any formula at all to say this. Like I don't think you need a formula to say what I just said. If you do, I think that means you're a little confused. Because this is not meant so that the person sits here and memorizes these formulas. Does that make sense what I'm saying?
Yes.
Yeah.
And then you just obviously add it all together at the end.
Right. Some of it is meant to memorize, but not all of it. All right. So you got to be careful with that. Like that's something that I don't know if teachers say this or how it ends up happening or whatever, but like it's not always really a good idea to just keep adding all, just keep memorizing all the formulas. It, like you should just think about the picture. And if you could do it by just thinking about the picture, then don't bother with the formula. Does that make sense? Does that make sense? Teresa?
Yeah.
Yes.
I mean, some of them you have to remember, but if you're sitting there and thinking that it's like a list of formulas and that each one's going to be able to somehow tell you the answer and whatever, and you just got to pick that through the list, that doesn't usually seem to work very well. All right. If there's a couple of them you feel like you need to memorize, and that's what you end up doing, I think that could end up working. All right. Find the volume of this thing. All right, so how do I find the volume in this case?
Length
Oh,
or
it's
Times height.
What'd you say, Jonathan?
base and height.
The volume is the, but say area of the base, okay?
Length with times height.
Right? The area of the base is just the length times the width. Then we have to multiply times the height. So in this case, all that really means is multiply everything together. So then that's what, 6 inches times 5 inches times 3 inches. So there's inch, 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 that's inches cubed. 6 times 5 is 30, times 3 is 90. So we get 90 inches cubed. Does that make sense? Does that make sense?
Yes.
Can you do the part again, please?
Do which part again?
When you got the volume, because it's confusing me when you did the length and the width because it.
6 times 5. What's 6 times 5?
Wait, so you're multiplying. I'm trying to figure out like what you're doing. So you're multiplying the length and the width, right? And then you take that number and multiply it by the height.
If you have 3 numbers and you're multiplying them, it doesn't matter which order you multiply them, right?
Okay.
Does that make sense?
Yeah, it does.
Because, but just think about it, right? 6 times 5 is, what's 6 times 5?
30,
30. What's 30 times 3?
90.
90. If I do it in a different order, 5 times 3 is 15. 15 times 6 would still give you 90. It's not gonna make any, all right? So the order doesn't really make any difference. You just gotta remember that you gotta multiply them. Does that make sense? Another reason why it's kind of easy to remember that you have to multiply them is because we need to get like inches cubed, right? Volume has like 3 dimensions. So we have to do like inches times inches times inches. You gotta multiply. Does that make sense?
Okay, so I have one question. So with the inches, I see you have the inches 3. So we're just counting how many inches that we multiplied, and that's how you get the inches cubed, the 3 cubed? Am
Well,
I-
let's say this. Let's say this. So like, if you have some length here,
Mhm,
right? Then they're gonna say this is a certain number of units.
mhm.
Let's say this is, I don't know, let's say it's 1 unit long, whatever that means. Does that make sense?
Yes.
All right. Then I go like this. And I make this length. Also,
Okay.
1 unit. And assume these are right angles here. Does that make sense?
Mhm.
Then this is really a square. Is that correct?
Correct.
Its area if it's a rectangle, which it is, the squares are rectangles, is just going to equal to length times width. The length in this case is, let's say, 1 unit. The
Mhm.
width in this case is 1 unit. What's 1 times 1? 1,
Right.
right?
Yes.
What's unit times unit? Well, I guess it would have to be unit squared. Does that make sense?
Yes.
All right.
Okay.
Then if I said you stack this up also 1 unit high, right?
Mhm.
Now all of a sudden, this length I'm saying is also 1 unit. The
Mhm.
volume reclaimed as length times width times height. This would now mean it's 1 unit times 1 unit times 1 unit. This would then be 1 unit cubed. So people say that the first ways that I wrote it, or people say this, 1 square unit, or they'll say 1 cubic unit. This is really what's referred to as a measure of volume.
Mhm.
This is a measure of area. And this is just a measure of length. So this, we said was one dimensional. This is two dimensional. This is three dimensional. Does that make sense?
Yes,
You understand what I'm saying?
yes, I get it.
So why I'm saying this is because when they write the units, it's actually a clue what they're talking about. That's why they write the units. Does that make sense? When they write squared, that means you're supposed to say it's area. When they write cubed, that means you're supposed to say it's volume. Does that make sense?
Yes,
Question?
no, I just need to
Teresa?
write down what you just said.
Don't forget also, just reminding everybody that the notes should be all online also. So if you click on course notes and then you click on this link and then you click open, it should just load the notes.
Those are really helpful.
It is helpful?
Yeah.
Okay, good. Because if you just click on C5 here, it
Mhm.
should load whatever I just wrote.
Oh,
Yeah.
okay,
You got me?
yes.
Now, I
You
would
can
still
get
write it
anytime, no
down.
matter
If
what.
I were you. Sorry, Thomas?
So you can get to this anytime, no matter what, right?
That's correct.
Okay.
That's- Right? I mean, I do suggest you write it down, but I'm just saying, if you want to refer to anything later, just write on there, you want to refer to it later, and then you can go and copy it down, and you can read it. Does that make sense?
No, I just want to sit there like,
Also, another thing I suggest you do is actually just listen to the video when you're doing it. Does that make sense?
Absolutely.
yeah.
Because it makes it a lot easier, hopefully. All right, and then you can still contact me if you have a question. All right. Find the volume and surface area, use 3.14 for this thing. Okay, let's do volume. We haven't really talked about surface area for this one yet. All right, so let's do volume. Volume. How am I going to figure out the volume of this guy?
Base time height.
The area of the base
Times height.
times its height times the height of the object is correct. All right, the height I think is pretty easy in this case. Is that correct?
Correct.
Yes.
So the height is definitely 7. All right. Well, how are we going to find out what B is? How do you find again, just remember that this again means, of course, the area of the base. Does everyone understand why I need to find that? We're going to take
Yes,
the area of the
because
base and stack it that many times. Does that make sense?
Yeah.
Yes.
All right. So how do I find the area of the base?
You're gonna multiply 5 by times pi?
Not 5 times pi. It's close though.
It's times 3.14.
Nope. Still messing something up.
Where
5 times pi r square.
Say it one more time.
5 times pi r square.
No, not 5 times pi r squared. All right. So we just said this formula a few seconds ago. We just said that if we have a circle and there's a certain radius, right? Then the area of this circle we said was going to equal to pi times r squared. Is
Yeah.
that correct?
Yes.
The circumference was, just reminding you, 2 pi r. Does that make sense? Teresa, one more thing also. When you do this one, you told me it was something like pi times r, right?
Yes.
That doesn't have 2 dimensions. That only has 1 r.
Mm-hmm.
Does that make sense? Like if r is like meters, that says pi times 7 meters or something like that. So this would just be meters, not meters squared. Does that make sense? Whereas this formula here has like pi times r in meters times r in meters. Then that really means we're going to end up something with meters squared. Does that make sense?
Yes.
Okay. So if they start saying area, it can't be just pi times r, because you don't have enough to say area. There's only one, there's only a length there. All right. So the area of this thing is pi r squared. So that means B is just going to equal to pi, which they're saying is 3.14 we should use, times r in this case is 5 centimeters squared. So this, all we would do is just multiply this out, I guess. So 5 times 5 is what? 25 times 3.14. So we get 78.5 centimeters squared. And then B here, we would just say is 78.5. Does that make sense?
Yeah.
So now we just multiply these guys. And then we have 549.5. What should the units be?
Cubic,
Say again?
cubic units.
Cubic, we know what type of units, not just units in this case, because they told us centimeters. So you have to say centimeters cubed or cubic centimeters. Does that make sense?
Yeah.
Question?
Mm-mm.
Nope.
Everybody okay with this?
Yeah.
All right, so now we need to do surface area of this thing. This is a little weird, but I find it kind of neat. So I don't know. The way I remember this is I don't know what you guys did when you were in middle school or whatever, but when I was in middle school, we used to play some game and it was called like kick the can or something like that. And then what people would do is they would take a can, because there would always be these cans lying around. Somebody would have a can of soda or some nonsense or whatever, or they would take it out of the garbage. And then the can, you would step on it, so it would become like really, 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 really small. And then people would start kicking it. You try and kick it through someone's legs, and then if you kick it through their legs, they would punch the person. So the thing was that people would kick this can, 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 and it was surprising what the kids would end up doing to the cans. So then I remember these kids, they would take the can and they would start like twisting it. And then they would take the whole like Coca-Cola part on the outside and they would it would like turn into like a square. So like this, if we unravel this thing, like this part right here, I'm saying now is this, and then the height remains the same. If I start trying to discuss what the area of like the outside part is, or sometimes people refer to this as the lateral surface area on the sides. The whole thing would like unravel, and the outside of this thing would be like more or less a rectangle. The base of the rectangle would be the exact same length as whatever this length is here. So that would be, I guess, 2 pi r, because the circumference is 2 pi r. The height would be h. In other words, the area of this thing would be 2 pi r h. Does that make sense? If you take the can and you kind of just like pulled it apart,
Right.
then forget about the top part and the bottom part for a second. Just the front facing portion of the can. It would flatten out and it would be like a rectangle. Like if I took this container, right?
Right.
And like the outside of this container from here all the way around to the outside, if I like cut it right here.
Right.
And then I took the whole thing and like opened it up. Does that make sense?
Yes.
It'd be a rectangle. Does that make sense?
Correct. Yes.
All right. And the base of that rectangle will be the same length as the outside of this circle. Does that make sense? Teresa?
Mhm. Yeah,
So that means the blue part would have to have area 2 pi RH. Is that correct?
yes.
If you wanted to
I'm getting
cover,
it. I'm
want to cover the can with wrapping paper
right.
on the sides, then you would need 2
Mhm.
pi RH amount of wrapping paper. Does that make sense?
Yes.
All right. Then the top parts here and the bottom part there, each one of these has the same radius. So the area of this one is pi r squared. The area of that one is pi r squared. So we would have 2 pi r squareds. So that means then that the surface area of a cylinder is 2 pi RH plus 2 pi r squared. Where this is the area of the lateral faces or lateral surface area, let's just say. And this is the top and the bottom. Does that make sense? Now, this formula I would say is a little bit more difficult, but it depends on the way you want to remember it. If you remember it the way I'm saying it right here, then you just really need to remember the formulas from before.
Mm-hmm.
Does that make sense?
Yes.
As long as you remember that this thing unravels to a rectangle. Any question?
No.
No.
All right, let's calculate this now. All right, so the surface area. Surface area of this thing is equal to 2 times 2 pi r times h plus we just said 2 pi r squareds. So in this case, that would be 2 pi, r is 5, h is 7. They want us to use pi as 3.14, so 2 times that is 6.28. R squared is 5 centimeters squared. Now we just have to type this in our calculator. Does that make sense?
Why isn't
So-
525?
Sorry?
Why isn't 525?
I said 5 centimeters squared, so you still have to square it here. If once you
Oh.
square it, it becomes 25. Does that make sense?
Okay, I got you. Mm-hmm.
You're right. You can write it as 25. There's no problem with that. All right, so 6.28 times 5 times 7 is 35. So this is 219.8 centimeters squared. 6.28 times, you said 25 is right, so you get 157 centimeters squared. Adding these two values together, we get 376.8. Any question with this? Does it make sense, guys?
Yes.
Yeah.
That's not cubed, it's squared, right?
Because it's area,
Okay, just wanted to make sure.
and because this says R times R, so you'd only get centimeters squared. This says R times H, you would only get centimeters squared. There is no third one. Does that make sense?
Yep.
Question here? All right, a sphere. These you more or less just have to memorize. All right. A sphere, the volume of a sphere is 4/3 pi r cubed. The surface area turns out is 4 pi r squared. there is one nice way to remember these, but it's only if you've done calculus before, and I don't even think it's that nice. So I would say it's just worthwhile just to memorize these things. Does that make sense? 4/3 pi r cubed, 4 pi r squared. All right, a right circular cone and a pyramid. So all you have to do to remember these things is the volume of these is, instead of it just being base times height, it's 1/3 base times height, all right? I think you should also just memorize that. So all this is saying right here is this is pi r squared h. This is pi r squared h. This is just 1/3 of that previous formula. These things I said, these have volume b times h. This says 1/3 b times h. All you have to do is remember 1/3 times the volume if it wasn't a cone or a pyramid. Does that make sense? All right. This part, I don't know if they're gonna make you do this or not, but let's just do it just in case. So the base here is pi r squared. This I would just memorize. This is, like, if you draw this thing, and this length right here is r, that length right there is h. If I wanted to figure out what this length right here was, I could use the Pythagorean theorem. So c squared is equal to a squared plus b squared. C, let's say, is this one. So that means c squared is going to equal to a, let's say, is r. B is h. So c squared equals this. So if I take square root, you get c is equal to the square root of r squared plus h squared. So this value here is square root of r squared plus h squared. This is r. You need the pi because it turns out if you unravel this whole thing, it would start looking like this. Like sort of like a piece of paper with some sort of circular arc here, as opposed to it just being a triangle, right? It turns out to find the formula, that would be the right way to find the formula in this case. But I would just remember it based off the fact that sometimes people say that this value here, sometimes they call it the slant height. So if you just take the pi times the radius, but now you have to multiply times the slant height also. Because why do they say that this makes sense? Because the previous formula was 2 pi r times the height. Now we're doing pi r, but times the slant height. Does that make sense? Question? All right, so they summarize this here a little bit. So if the top and the bottoms are matching, it's just the area of the base times the height. If it's a pyramid or a cone, it's 1/3 area of the base times the height. If it's a sphere, it's 4/3 pi r cubed. You can remember sphere also because you need r times r times r. All right, find the volume and surface area of this thing. All right, so the volume is 4/3 pi r cubed. The surface area is 4 pi r squared. All right, why don't you do these and then tell me what you get. Don't forget on the first one also, they did not give you the radius in the question. Also, don't forget that you need to use pi as 3.14. Anybody got one of them?
The surface area is 687.7856.
That's correct. Good.
And then is the volume 1692.296.
I got 16. No, I got something else.
Please hold.
Try it again. Anybody else got an answer?
Did you get 69.708?
For the volume?
Yes.
No.
Is it 1,696.52?
54.
Oh,
How did you get that part wrong?
I don't know.
Neither do I. That means you rounded. You must have rounded in the middle. Were you rounding in the middle?
I don't think so, but maybe. Let me see again. Oh, yeah.
Yes?
Yeah, I rounded. Okay.
Okay, don't, it's important. We need to discuss that actually, but don't ever round in the middle of any of the calculations. Does that make sense?
Yep.
Only round at the end, okay?
Wait, Professor. So it was, the volume was supposed to be 4 divided by 3 multiplied by pi multiplied by the 7.4 to the power of 3, right?
Yes, that's correct.
So it's not 169.52? That's what came up again.
169.53781 I got.
Oh, okay, fine.
Close, very close.
Okay.
Just 1 second while I finish writing out the rest of these. 0.00058 meters squared. All right. So I got this when I ended up doing it. The volume is 4/3 pi r cubed, so that's 4/3 times pi. So when I did that, 4/3 times 3.14 times 7.4 cubed. Don't forget to do the 7.4 here. I ended up getting this number. Does that make sense? If you want me to show you, I can do it again on here. 7.4 cubed times pi, which is 3.14 times 4 divided by 3.
Okay, I got you. I was multiplying 1.33. That's probably why I was off by like that little bit.
Oh, okay. Yeah, you can't round the frac. Don't just don't round it. There's no
Okay,
point. Does that make
okay,
sense?
I got it.
Just don't round stuff. All right, until you get to the end. Surface area is 4 pi times r squared. So that's 4 times this value squared. I would do this one first. Does that make sense? Any question with this? Does it make sense, guys?
Yep.
So this one's just like a slightly different application in terms of the formulas, really. Otherwise, it's just doing it on your calculator. You got to remember that the volume of a cone is 1/3 of the base times the height, area of the base. Note also, every single time I write area of the base, I'm writing a capital letter just to distinguish, so it's easier for me to see like which one's which. So the area of the base times the height, the area of the base is pi r squared. So the height is 7, r is 3. So this is 1/3 times 3.14 times 3 squared times 7. So if we're going to do this in the calculator, this would be 3 squared is 9 times 7 times 3.14. And then we got to divide this by 3. So we get this 65.94. But this would be meters cubed because it's a volume. Does that make sense, guys?
Yep.
Does anybody have any question so far? Now this one's just really kind of just like a more annoying formula, and that's really it. I just wanted to say also that you could take the pi out of this whole thing, since there's a pi in both parts, and then you could write it as r times the square root of r squared plus h squared plus r squared here. And yeah, I guess you could kind of do it separately. All right. So let's just do this one completely again, actually. Actually, I'm going to take the r out also. So I can write it like this. I don't know. I think that's slightly easier to calculate. All right. So r is 3 meters. Pi is 3.14. Well, that I guess we could just do that. 3 times 3 is 9. 3 times 14 is 42. So this is 9.42 meters times whatever all this stuff is. Square root of r squared is 9. H squared is 49. R is 3. Does that make sense? So then 9 plus 49.
Wait, where is the 3 coming from? Where are you? You put 9.42, which is the multiple of 3.14 by r, which is 3. And then you put the parenthesis, which is 3 square, and then 7 square, and then plus supposed to be pi r square. Is that the formula I see on top?
No, I wrote it. I said I take the r and the pi out of these. There's an r and a pi in both of these, so I factored it out. So we have r times pi times this. This is another way to write the same formula. These two are the
So
same thing.
w-
I'm
w-
doing this here.
where does that one start? Because there is a plus sign, so I'm confused. I'm sorry.
So this says R squared plus H squared. This says R squared plus H squared, right?
Okay.
And then this says, and then this says plus R, which is plus 3. That's where the plus 3 comes from.
Okay. Okay. Let's go back to the surface area formula. So what you're indicating there is two separate formula. You're saying this formula and this formula can work?
No, this is just multiplying and stuff like that. So if I say to you that you have 3 times 5 times A, and then I say to you, you have 3 times 5 times B, another way to write this is to say you have 3 times 5 times A plus B. So I just wrote it this way also.
Okay.
Does that make sense?
Let's go to our formula and I'll let you know if I understand what you're saying. In principle, I understand what you did.
Well, this is just multiplying. So like this is just a multiplication thing. This has nothing to do with
You
this has
took
nothing
out
to do with this.
you took out the common factor and you just put it in parentheses. I got
That's
that.
all. That's all I did. So the so whether you want to write it this way here or this way, it makes absolutely no difference. Does that make sense?
Okay, that's what I needed to know. I needed to know where that equation ends. Okay, got it.
Okay. I need to go and send some announcement out to the entire class because I need to tell them I'm not going to post it if this is how many people are going to show up to class. So I'm going to stop posting recordings.
But professor, that would be hurting us, those that did attend.
Well, that's why people are supposed to take notes and stuff. But
Okay.
I can't do anything about it. People can't just, there can't be this few people attending and participating and stuff like that. So, recordings will no longer be posted due to the fact that students are failing to attend class. Sorry, but class is required.
I mean, how many people are registered for the class?
What do you say?
How many people are registered for the class?
You don't want to know.
Wow.
Probably 30 people nearly.
Wow.
So,
So now we need to take notes as
well, you should
instead
always
of
be taking
doing the
notes.
video. Hmm?
Well, the notes are still posted online. The notes are still posted online, but I can't, so you're still gonna be able to see the notes, but,
Okay.
all right.
So what if we're like honestly, I'm not that good at math and I always like look back at the videos, even though I attend class, there's not a way to have the video for any students.
No, not anymore. All right, sorry. I don't think people are paying attention. There's only like 2 or 3 people who are answering questions. And this is, and right now there's a total of 6, 7, 8, 9, 10, 11, 12, 13 people who are logged in. All right. All right, if a spherical tank of 4 meters in diameter can be filled with liquid for $850, find the cost to fill a tank 15 meters in diameter. Right, anybody have any idea how I'm gonna figure this out?
First, you would write out the equation for the spherical tank, which would be 15 meters in diameter.
What do you mean, what equation?
Never mind, actually. to find the volume of the tank.
Yeah.
Find the volume of which tank?
The spherical tank with 15 meters in diameter.
All right, we're definitely gonna have to find that volume. The thing is that there's kind of, I guess, all right, I'm gonna write it out like with the whole thing, and then I'm gonna write it out with just the what do you call it? With kind of like, I guess, like the faster way to do it. All right. So but I don't think the faster way is really easy to understand unless we do it the first way, right? So it's like they tell me that they have some tank and it's gonna end up costing $850 to fill that tank.
Mhm.
And then we want to fill some other tank. Well, I need to find the volume of both the tanks. Does that make sense?
Mhm.
All right. And then I just need to see how many of these original tanks fit into the new one. And then I could just say, oh, if there's 3 of them, then it's 3 times 850 or something like that. Does that make sense? All right. So the volume of well, let's remember what the volume formula is first. The volume of a spherical tank is 4/3 pi times r cubed. So the volume of the 4-meter tank is going to equal to 4/3 times 3.14 times, what's R?
In question. Where are the 4 meters actually coming in?
2.
2 is correct. Just remember that diameter means, like if this part's 4 from here to here, that means it's 2 from there to there and 2 from there to there. So it's 2 cubed. Does that make sense? All right, let's figure out what this number is. This is 4 divided by 3 times 3.14 times 8. So that's 33.493 forever meters cubed. The volume of the 15-meter tank. Somebody tell me how to calculate that one. What do I have to calculate?
The same thing.
4/3
Four
of
over-
I, and then 4, or no, it would be 7.5.
Perfect. So 15 divided by 2, 7.5. Just don't forget to cube it. Does that make sense? Any question with that?
Nope.
All right, so then this would be, let's see what this is, 4 divided by 3 times 3.14 times 7.5 cubed. Is that right? 824. That was right, actually. Let me just make sure I typed it correctly. 7.5 cubed times 3.14 times 4 divided by 3. 1766.25 meters cubed. Does that make sense?
Yeah.
Yes.
All right. So now what I'm going to do is I'm going to write the cost of the 4-meter thing is to the volume of the 4-meter thing, as the cost of the 15-meter thing is to the volume of the 15-meter thing. The cost of the 4-meter thing is 850. The volume, or let's write it this way, actually. Sorry. The cost of the 15 is to the cost of the 4, as the volume of the 15 is to the volume of the 4. The cost of the 15, we don't know what that is. So then let's say that's X. The cost of the 4, we know what that is. It's 850. The volume of the 15, that was this number. And then the volume of the other one is that number. Does that make sense? that make sense, guys?
Yes.
So that means then the cost overall should be 850 times whatever this ratio is. Because that's the number of times that the small one's gonna fit in the big one. So 1766.25 divided by 33.4933 whatever times 850.
Why not just find out the cost per 1 meter square foot or 1 meter cube and multiply it by 15?
Same thing.
Less math?
No,
Okay,
exact same thing.
okay.
Because effectively all you're saying is, you're saying instead do this. Volume of 15 divided by cost of 15. Wait,
No, of
No,
the
you're
given before.
cost of 15 divided by volume of 15 is equal to cost of 4 divided by volume of 4. That's the only difference that you're doing.
Mhm.
All right, it's the same thing. Does that make sense?
Okay,
Yes.
Do you understand or no?
I understand. Yeah.
It's 6 of one, half dozen the other. It's like, oh, divide these two first, then multiply by that one. Divide these two first, then multiply by that one. It's the same thing. So then this is, it's fine if that's the way you want to do it, though. Like, that's a perfectly good way to do it, but it's not any different, right? So something like this. Does that make sense? Okay, now I wouldn't do it either one of these two ways. All right, I do it slightly different than both of these. Okay. So let me show you that way. All right. It's similar to this that I did here, but there's like one part that I'm going to do where I can kind of skip like a little bit of this stuff, and it makes it easier to calculate and easier to type it into the calculator. All right. We're still going to start off with this first thing here. We're going to say C15 over C4 is equal to V15 over V4. We know what C4 is. C4 is $850. Does that make sense? All right, now the only thing is instead of doing it the way I was doing it before, I'm gonna write these in terms of their actual formulas. V15 means I have to take the 4/3 times the pi times the big radius cubed. And then I'm gonna divide this by 4/3 times the pi times the little radius cubed. Does that make sense? The reason why I want to do it this way is because I can just get rid of all this crap. It all cancels. Does that make sense? So then that would mean that C15 has to equal to 850 times whatever the big radius is cubed over the little radius cubed. That's a lot easier. Like, that's a lot less stuff to do. So here, all I would have to do is the big radius was 7.5. The little radius is 2. And then we cube this. And then we multiply this by 850. And it gives us the exact same answer. Does that make sense? Now, one way you could remember this without actually doing it, I guess, as much, is just to remember that this has to be a ratio of the two radii then. But it's cubed because it's volume. Does that make sense?
That's what I was wondering, the way for you to get your ratio to that would be the simplest way.
But this, I mean, it's not that easy to say this, but it is a lot easier to type in the calculator. Does that make sense? Because it's like, why am I sitting here and doing 4/3 times 3.14 times this? And then I'm gonna do 4/3 times 3.14 times this, but then I'm just gonna divide them anyway. Like the 4/3 and 3.14, we can just cancel. Does that make sense? It's like you're doing it and then you're undoing it right afterwards. Does it make sense, this part here? Does anybody have a question with this?
Makes
Sarah, does
sense.
this second part help, Sarah? Thomas, you were saying something?
I'm saying it makes sense. It's just getting to all of it. Now you have to really make sure that that's exactly what you do from now on.
Well, this is one of the harder questions. Like, we're almost done with this whole chapter. So this is one of the hardest things in the whole chapter. Does that make sense?
Okay.
All right.
Can we do another one like that? So I would say, because I'm pretty sure everybody else is thinking it. At least
Yeah, I'm sure we can.
get to the
I'll try and
ratio.
find another one, definitely. All right. Let's do this one. Let's finish up the stuff first, and then we'll come back to it. All right. Find the value of X here. Why don't you guys try this one? Tell me what you get. If you know how to do it. If you don't know how to do it, tell me. Because I'd say this is more like a more normal type of question that they would ask. The other one's probably like the hardest possible question they'd ask on the test.
I honestly don't think I understand this question.
What does V equals 60 mean?
I know volume is equal to area of base times height, but I'm trying to like plug it in and it's just kind of confusing.
What's the area of the base? What do you- James,
Would
what's
that
the
be
area of the base?
6?
6 is just one length. That's not an area, right?
Oh, you're correct. Yeah.
So you gotta do the area of the whole base. Does that make sense?
Okay.
What's the area of the base?
Is it 48?
6 times 4 is
24.
24, not 48. Does that make sense?
Yeah.
Okay, then what are we gonna do?
Wouldn't that be simply 60 is 6 by equals 6 by 4 by X?
That's correct. So
Okay.
we just use the formula volume equals length times width times height. 60 then would have to equal to 6 times 4 times whatever the height is. In this case, they're calling that X, I guess, right? So we just said 6 times 4 is 24. So now what do we do?
You subtract.
Divide 24 on both sides?
Yeah. Divide.
Subtract's not gonna work because it's not adding. Does that make sense?
Yeah.
Divide by 24. So then we would end up getting that X is equal to 12 goes into both of these things. So this is 5/2. What are the units?
Cubic units.
Nope. Is this a volume?
Well,
It has to be cubic units when it's a volume. Is X a volume?
Oh,
No.
an
So what should it
area
be?
squared.
X is not an area.
So whatever the measurement is it centimeters? Is it meters?
Right. It's just units. Does that make sense? We don't know what it is.
Okay.
Because they just said this is like units, like they didn't say, you're right, it could be, if they had said centimeters, then we would put centimeters. If they had said meters, then we would put meters. My point is, it's not centimeters squared, it's not centimeters cubed, is that right?
Yeah.
It's units, right? Any question with this one?
No.
All right, so I guess that's the end of that. So let's do one where we talk about these ratios. Maybe I should just make one up. Which thing you guys talk about? Let's do. Let's do an area. That's what we'll do. All right, let's say a room is in the shape of a circle. And has a diameter of 10 feet. The cost of carpeting for this room is, or was, let's say, $1,000. Determine the cost to carpet a circular shaped room with a radius of 1 foot. Or let's say, what is the cost, I should say. What is the cost to carpet this guy?
It would be
Does it make sense?
Yeah.
You want to try it first and then me do it, or you want me to do it?
It is
Can
$100,
you just
right?
walk it through?
What did you say?
Can you walk it through?
Yeah.
So it wouldn't be just a tenth of the cost of 10 feet, right? It doesn't work like that, right?
The problem is that 10th of a cost of 10 feet, sorry?
Okay. The first one with the given information is 10 foot and the cost is 1,000.
Mhm.
And the second one is 1 feet, right?
Right. Yeah.
Or like, what is, so it would be 2 feet in diameter, right?
This
So,
one would be 2 feet in diameter, is correct.
yeah, so can I say, well, this is 1/5 of the first one, so the cost would be 1/5?
Okay, that's what we want to talk about, but you cannot say that. Okay, sometimes you can, but not in this case. So
Okay.
let's try and let's do a, before we do this one, let's do another one then, okay? Let's say it was a square first, all right? Let's say the room is a square and the side length is 10 and it costs $1,000 to carpet it, okay? What is the cost to carpet a square room with a 1 unit length, side length? Okay. I think it's gonna be a little easier for this one first, because it'll be a little easier to understand if we just, with the drawing a little bit, all right? So someone says, this is 10 by 10. And it costs $1,000 to carpet the whole thing. All right, now you're saying like, well, can I just, you're kind of saying something like, hey, maybe I should just do like 1,000 divided by 10, really, right? Because this is 10 and this is 1, so it's like they divided by 10, so maybe I should divide by 10 also. That's not correct. Turns out you should divide by 100. And if it was volume, turns out you should divide by 1,000. All right, 10 times 10 times 10. So the reason why is that if I wanted to say what the cost is per unit area in this case, then that would mean it's $1,000 per 100 units squared. That would mean it's really $10.
But
Yeah, $10 per unit squared. In other words, each of these little squares here is going to cost me $10 for the carpet. Does that make sense?
Yeah.
Now they're asking, what is the cost of carpet a 1 unit length room or whatever? Well, that means the answer has to be $10. Does that make sense?
Yeah.
Sarah? Yes.
Okay, I don't know what 1 unit length is anyway. What is 1 unit length? What does that mean? The English, I don't understand.
That's the length of 1 unit.
it's not defined. It's either 1 foot or 1 centimeter is not defined. Unit
Yeah,
itself.
whatever the unit is, I just didn't mention it. You want to say it's meters, then whatever. 1 meter length.
Okay.
I mean, okay, this shouldn't be too confusing. Like this, there's 100 of these squares in here. Is that correct?
Yeah.
Yes.
So if the whole thing's 1,000, then each square is gonna have to be 1,000 divided by 100. It's 10.
Oh,
Is
yeah,
that
yeah,
correct?
yeah, 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 yeah. I'm sorry. I spaced out.
So then my point is so then the final answer to this question is actually $10, right?
Yeah.
But you see, Sarah, you were mentioning that, hey, it looked like we were taking the side length and really we're dividing the whole side length by 10. But the problem is you're doing it in 2 different dimensions. So you have to divide by 10 and then 10 again. Does that make sense?
Yes, yes, yes.
Does that make sense?
Yes, it does. Yes.
All right. Now, another way to do it is the cost of the small one to the cost of the big one has to be equal to the area of the small one as compared to the area of the big one. Does that make sense? The cost of the small one, let's call that X. The cost of the big one, well, they told us it's $1,000. Then the area of the small one is 1 meter squared. The area of the big one is 100 meters squared multiplied by 1,000. Does that make sense?
Yeah.
Yes.
You get $10. Does that make sense?
Yep.
Question with this?
No.
All right, let's go back to the other one now. All right, so we have a room that's in the shape of a circle. It has diameter 10 feet. The cost of carpeting for this room was $1,000. What is the cost to carpet a circular shaped room with a radius of 1 foot? All right, so the cost to do the small one should be related to the cost to do the big one, as the area of the small one is related to the area of the big one. The cost of the small one, let's call that X, I guess. The cost of the big one, 1,000 the area of the small one is, let's say, pi times little r squared. The area of the big one is pi times big R squared. Does that make sense?
Yeah.
Pi cancels. Is that right?
Mm-hmm.
Little r. What is little r?
1.
1. So 1 squared is just 1. What's big R?
5.
Mhm.
Oh, well, 25.
So the 5 is right. So then that means this is going to be 25. Does that make sense?
Yes.
So that means then x is going to equal to 1,000 times 1 over 25, which really means just divide by 25. So what's that? 25 goes into 104 times 10 is 40. $40. Does that make sense?
Yeah. That's a lot clearer.
It just takes a couple examples. Does that make sense?
Yeah.
This is just not that easy. But I do think writing it in this ratio form it does help. Does that make sense?
Yeah, that helps a lot.
There's like a lot of crazy things in the formula, like they're gonna cancel. Does that make sense?
Mm-hmm.
Teresa? Question?
No, I'm a little baffled, but I'm trying to figure it out. Can you hear me? Oh, yeah, I do have it on.
No, I heard you. All
Okay.
right.
Okay, so I got the part where the pi square had crossed out.
Let's just try and do it with the numbers, all right, instead of writing the variables, all right?
Okay.
The area of the small one is pi r squared, so that's 3.14 times 1. Does that make sense?
Mhm. Yes.
The area of the big one is 3.14 times the radius here is 5, so it's 25. Does that make sense?
Right. Oh, yes.
All this is doing is just seeing how many times like the small one fits into the big one or the big one fits into the small one. Is that correct?
Yes.
Okay. So then I would know like a factor associated with like how much stuff I have. All I'm going to do is take that factor and either multiply it or divide it with this number. Does that make sense?
Okay, yeah. I got it now.
That's all I'm doing.
Yeah.
Does that make sense?
That makes sense. Yes.
All right. It's just the thing is that like you don't want to have to reason all this crap in your head the way I just did it. That makes it harder. If you can use an
Mhm.
equation or write it down, it actually makes it simpler. Does that make sense?
Yes.
Okay. Any questions, guys?
Basically, cross multiply essentially.
Pretty much, but in this case, we don't even, I kind of hate it when people say cross multiply
Yeah.
because like, there's almost like never a time where it's a good thing to do. So like the thing is if I have like x over 5 equals 2 over 7, right? You could cross multiply. Then you would end up getting 7x is 10, but then you still have to divide. And then you get 10 over 7. Does that make
Yeah.
sense?
Yeah.
Like the reason why I don't like it is because all you're ever supposed to do is say isolate the variable. How do you isolate the variable? You get rid of the other crap. Does that make sense?
Yeah.
How do you get rid of the crap? Well, it's dividing, so I should multiply. So I should multiply. Does that make sense?
Got it. Yep.
And you get the same 10 divided by 7. 10 divided by 7. But it's like the reason why I don't like saying cross multiply is because you can make it makes the numbers bigger first.
Yeah.
Then you have to make them
Got it.
smaller again. Like it doesn't really make any sense. I don't know why they teach
Make
it.
it bigger to then multiply. Yeah, to then divide it. Yep. Got it.
It just doesn't make any sense. You're doing unnecessary steps. So that's the I don't know. I don't know why people teach this crap, honestly. I think it forces, I think it's they're saying something like, oh, my kids are having trouble with fractions, so I should get rid of all the fractions. No, you should do the exact opposite. You should make people do more and more and more and more of the fractions until they're like, yo, I understand. Does that make sense? Don't convince someone they shouldn't do it. All right, that's what they do. Does that make sense?
Yep. Got it.
All right. So I guess that was that. Let me see if I have one more on here that I have with that question. No, I don't. Thomas, is that a little better? Does anybody have any questions about anything from the geometry chapter? Guys? Does anybody have any questions about anything? Otherwise, I have to go on to the next unit.
No.
All right. All right. Next unit is about counting. Counting can be hard. Okay. There are formulas here. There's not that many of them. You have to know how to use them. Does everybody understand what I'm saying? All right. But the only way to know how to use them is to understand it in this case. So that's why people think this one's a little harder sometimes. All right. So in this chapter, counting means finding the number of objects with certain characteristics. One method is systematically listing the objects being counted. This is only practical for relatively short lists. The approach must be systematic to ensure that all objects are counted, but none are counted twice. The results for simple one-part tasks can often be listed easily. List the different outcomes to tossing a fair coin. What are the different outcomes that are possible?
Head or tail?
Yep. So we would say there's two ways to do that. Is that correct?
Yes.
What are the different outcomes when rolling a die?
1, 2, 3, 4, 5, 6.
Okay, so now he says, if there's some sort of task where it actually requires two things to be done, so something has to happen first and something has to happen second. When counting the number of outcomes for a two-part task, you can use systematic listing. Sometimes it's easier to list all possible outcomes using a product table and then pick the outcomes you want. All right, like I guess he didn't say something I said earlier, but I said to you, let's say if you consider two dice, X1 and X2, X1 can take on values 1, 2, 3, 4, 5, or 6. X2 could take on values 1, 2, 3, 4, 5, or 6. These dots would represent all the different possibilities. Does that make sense?
Mhm.
Either the first die could be a 5, and the second die could be a 4. Does that make sense?
Yes.
Or maybe the first die could be a 4, and the second die could be a 5. He's calling this product table. It's the exact same thing. It's just written in a different format. Does that make sense?
Yes.
So then, now, the problem here is that he's not really being clear what he really wants here. Usually they'll discuss that they want the sum of the two dice or something like that. He didn't mention what he wants. So all I can say here is that if I list an ordered pair, then this is the first die, and this is the second die here. In this case, it looks like this is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. This would be 2, 1, 2, 2, etc. Does that make sense?
Yes.
All right. Whichever way you want to write it, it doesn't make any difference. All right, it's the same thing. Any question with this?
No.
But this would be an example of systematic listing, because this is a way to list out every single possibility. Does that make sense?
Yes.
Here's another way. You could do like, you could say the first die here could be a 1, a 2, a 3, a 4, a 5, or a 6. Then the second die could be, well, if it's a 1, it could be a 1, 2, 3, 4, 5, or a 6. Then the 2 could be a 1, 2, 3, 4, 5, or 6, etc. Does that make sense?
Yep.
Yes,
All right, same thing, just different diagram, really. Does that make sense?
yes.
This is sometimes referred to as a tree diagram. Right? This stuff.
Mm.
All right, so now he says, use the product table above to count the following. And how many ways can the sum be a 5? See, I knew they were gonna say it wrong. All right, if they're, they should have said here, use a product table, list all the possible sums for rolling 2 distinct dice. Does that make sense?
Mhm.
1 plus 1 is 2. 1 plus 2 is 3, 4, 5, 6, 7. 2 plus 1 is 3. 2 plus 2 is 4, 5, 6, 7, 8. Does it make sense how I'm filling this out?
Yes.
This would be 4, 5, 6, 7, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 7, 8, 9, 10, 11, 8.
Wait, what are we doing, Professor?
Finding the sum of the 2 dice. Question?
You
I
would
did
only do that if,
Sorry?
I did not understand the numbering.
5
the addition of
plus
the two dice.
4 is 9. So if the second die is a 5 and the first die is a 4, then the sum would be 9.
You
Oh,
would
okay.
do this if it asks for the sum, right?
Say again?
You would only do this if it's asking for the sum.
That's correct. Otherwise, you have to do it the other way that I was labeling it out
I
with all the
just-
different.
Yep, okay, perfect.
The other way is just a slightly more general way to say it. Does that make sense?
Yep.
In this, so he was saying previously, like there's a particular characteristic that they're interested in. In this case, they're mentioning that they're interested in the sum. Does that make sense? Sarah, does it make sense?
Yes, yes.
This is just a way to write out all the possibilities, because otherwise it's hard to know how many ways there would be to get a 7 or something like that. Does that make sense?
Okay. I see the use of with your comment now. Yes.
Use the product table above to count the following. And how many ways can the sum be a 5? Like, this would be kind of a hard question if I don't do it this way. Does that make sense?
Yes.
All right. How many ways would the sum be a 5? What would you say?
4.
4. Does that make sense?
Yep.
Because we've written out the whole thing. Now, I think you could have done this without writing this one out. This one, I think you could do pretty easily, actually. You could just say, could be a 1 and a 4, could be a 2 and a 3, could be a 3 and a 2, could be a 4 and a 1. There's 4 ways. Is that right?
Yep.
All right, but some of these other ones, like, no way. Like, I don't want to do it without writing out the whole thing, right? So in how many ways is the sum a composite number? Composite just really means not prime. Okay, well, I guess we got to see which ones aren't prime. 2 is prime, 3 is prime, 4 is not prime. So there's 3 4s, 5 is prime. 6, there's 5 6s, 7 is prime. 8, there's 5 8s, 9 is not prime. 10 is not prime. So then 9, there's 4 of them. 10, there's 3 of them. 11 is prime. 12, there's 1. That means we got to add up all this stuff here, I guess. So that's 8, 13, 17, 21. Does that make sense?
Yep.
Really, this is really just knowing what prime means and composite, and then making sure you're able to write out the whole table. All right. He says, determine the number for which the sum is between 3 and 9. 3 and 9. All right, I'm gonna do this one slightly differently. Like, sure, we could just go and count all of this stuff. 3, this. Oh, wait, excuse me. I gotta be careful here. It says between 3 and 9. That really means from
4 to 8.
4 to 8. I was about to mess that up. Does that make sense?
Yep.
All right. So 4 to 8. I'm still gonna do it this other way though. So this is this, and this. Does that make sense?
Yep.
I'm just doing this as an example. You don't have to do it the way I'm saying it. You could just count the crap that I've already highlighted here. But I think it's pretty obvious that there's 36 total spaces here. Is that right?
Oh,
So I'm gonna do 36 minus the ones that don't count. So there's 3 over here. And there's what, 4, 7 is 10, 2, I mean, excuse me, 4 plus 3 plus 2 plus 1 is 10.
10.
So that means this is gonna be 23. Does that make sense?
Yep.
Otherwise, just add up the regular ones. You get 23 also. Any question?
Nope.
But the point is that sometimes it's easier to count the stuff that they're not asking for. All right? Like this one probably. He says between 3 and 12. Between 3 and 12 means 4 to 11. Well, it's everything but these 4. It's easier to just say 36 minus 4. Does that make sense? Does that make sense, guys?
Got it.
So that's referred to as complementary counting because you're counting the complement instead, and then you're just removing it from the total. Does that make sense? So just always ask yourself, is it easier to do it directly or do it indirectly? Okay. All right, construct a product table showing all 2-digit numbers using digits from this set. Again, like you don't really need to do a product table to do this. I think you can figure it out without doing that. I'm just gonna say that first, but since he's asking for a product table, we gotta make sure that you're gonna be able to say a product table also, okay? But all 2-digit numbers from this set, I could do a 1 with a 1, I could do a 1 with a 3, I could do a 1 with the 7. I could do a 3 with the 1, a 3 with the 3, a 3 with the 7. I could do a 7 with the 1, a 7 with the 3, a 7 with the 7. Does that make sense? The product table just helps me to write it down. So let's say we call this the first digit, and we call this the second digit. The first digit could either be a 1, a 3, and a 7. Second digit could either be a 1, a 3, and a 7. If I get a 1 and then a 1, I can get a 1, then a 3, a 1, then a 7, a 3, then a 1, 3, then a 3, 3, then a 7, 7, then a 1, 7, then a 3, 7, then a 7. Does that make sense?
Yes.
Any question here?
Mm-mm.
Consider the club with 5 members: Anthony, Ben, Cindy, Douglas, Edith. Assuming all members of the club are eligible, but that no one can hold more than one office, list the different ways the club could elect both a president and a treasurer. Okay, let's just call them A, B, C, D, and E though. Does that make sense? I don't want to keep writing them. Does that make sense?
Mhm.
All right, so let's pick the president first. Or let's do this over here, actually. I don't want to write it over here. So let's pick the president first. And then after that, the president could be either what? A, B, C, D, or E. Is that correct?
Yep.
Then they said they wanted a treasurer, right? So if A was selected as president, then I would only be able to select B, C, D, or E as treasurer. Does that make sense?
Yes.
So then I could get AB, I could get AC, I could get AD, and I could get AE. B, I would only be able to select A, C, D, or E as treasurer, because I can't put B as both president and treasurer. So this would be BA, BC, BD, and BE. Note that BA and AB are not the same. Does that make sense?
Yes.
What would I be able to pick here?
A, B, D, E.
Mhm. And again, the thing that's all I'm really doing this for is to remind you that you can write these things out. All right. If you
Mm.
write them down, you'd be surprised how many of them you'll be able to do. If you don't write it down, you'll be surprised how many of them no one will be able to do. All right. You need a way to write it out. Does that make sense?
Yes.
Yep.
E could go with A, B, C, or D, I guess.
Mhm. Yes, sir.
But I'm telling you that if you write it out on your test, you'll still be able to finish. Okay? Any question?
No.
No.
Nope.
All right. It says, assuming all members are eligible, but that no one can hold more than one office, list the different ways the club could elect a president and a treasurer. If the two officers must not be the same gender. Well, honestly, like, I don't even know if I know everybody's gender.
That's true. That is true. Because Ben can be a female.
I mean, really, any name could be anybody.
Yeah.
You know what I mean?
True.
So like,
Mhm.
whatever. All right, let's just assume, I guess Anthony, people would typically assume is male. Ben, I guess let's assume that person's male. Cindy, I'm gonna assume is female. Douglas,
Mhm.
male, I guess.
Yeah.
Is that male?
Male.
What do you think?
Mhm.
Male? Edith, I'm gonna go with female, right? I guess. All right, so then, the list the different number of ways the club could elect a president and a treasurer if the two officers must not be the same gender. Okay. All righty. So, we could pick Anthony as El Presidente. If Anthony is the president, then we could have him with Cindy, or we could have him with Edith. And now we're done with Anthony as president. Does that make sense?
Mhm. Yes.
Yeah.
All right. Then now, if we don't do Anthony as president, I guess we can make good old Ben president. If Ben is president, then Ben can go with Cindy, or Ben can go with our girl Edith. All right. So then now, what else do I do?
You could do Cindy.
We could do Cindy, but let's finish dealing with these men first.
Okay,
Does that
so
make
then
sense?
we do Douglas.
Douglas, because you gotta kind of do it in order, just so you don't miss something. Does that make sense?
Mhm. Yes.
So then Douglas could go with Cindy, or Douglas could go with Edith. Is that right?
Mhm. Yes.
All right, now we're gonna do the ladies. Is that right?
Yes.
So what do we do now?
Cindy can go with Anthony.
Cindy can go with Anthony. Cindy
Ben.
could go with Benjamin.
Ben.
Cindy can go with our boy
Douglas.
Doug.
That's it.
All right. And then now we gotta do Edith. Edith can still be president. Edith could
Yes.
go with
Anthony.
Anthony. Edith could go with Ben,
Mhm.
and Edith could go with
Douglas.
Dougie. Is that correct?
Yes.
You get what I mean, though? Like, you don't necessarily need all these tables and diagrams and all that also, if you just
Correct.
systematic out. Does that make sense?
Yep.
Yes.
Okay. Question?
No.
So now he says the tree garbage, all right? Construct a tree diagram showing all possible results when 3 fair coins are tossed, then list the ways of getting more than 2 heads.
Hmm?
Tell me all the possibilities when you toss 3 coins.
Heads and tails, tails and
Mhm.
heads.
Nope, 3 coins.
Heads, 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 tails, heads, heads, tails, 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 heads, heads.
No,
That's correct. That's correct. But do it in some sort of systematic order. You're not going systematic. Okay. So like heads, heads, head. You did it. These have 0 tails. Is that correct?
Yep.
Now we could have 1 tails. Fine. I get tails. I could get heads. I get heads. I could get heads, tails, heads. I could get heads, heads, tails. Is that right?
Yep.
Then we could get 2 tails. 2 tails would mean tails, tails, heads, tails, heads, tails, or heads, tails, tails. Is that right?
and tails, tails, tails.
Then the last one's gonna be tails, tails, tails is correct. Does that make sense?
Yes.
Now it says list the ways of getting more than 2 heads. More than 2 heads, there's only one way. You'd have to get 3 heads. Is that correct?
Yes.
All right,
Yep.
he says do it with a tree diagram. I'm just gonna do it with a tree diagram real quick though, all right? So there's the first coin, there's the second coin, and there's the third coin. The first coin could either be a heads or a tails. If the first coin was a heads, the second coin could either be a heads or a tails. If the first coin was a tails, it could either be a heads or a tails also, right? Then the third coin, if the first 2 coins were heads, third coin could be either heads or tails. If the first coin was a heads and the second coin was a tails, it could be a heads or a tails. Same thing here, same thing there. The first path would mean I get the heads, heads, heads. Then I could go this way, I guess. Then I would get heads, heads, tails. Then we could go this way. We get heads, tails, heads. Whoops. Heads, tails, heads. Then we get heads, tails, tails. Then we get tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. Same thing. Does that make sense?
Yes.
Any question?
No.
Consider the club with 5 members. Again, our favorite people. List the different ways that the club could arrest a president, a secretary, and a treasurer. If the president must be a man and the other 2 must be a woman. I don't want to do this anymore. All right, it's the same stuff. All right, instead, what I want to do is what they're going to start asking after this. I want to do count the number of ways. Does that make sense?
Hmm.
All right, so let's talk about how we can count this crap, okay? All right, so we were doing this one before, where it was president and treasurer. Is that correct?
Yes.
There's something, I think we mentioned this previously, but it's referred to as the fundamental rule of counting.
Mm-hmm.
The fundamental rule of counting effectively means if there's A ways to do A and B ways to do B, there should be A times B ways to do A and B. Does that make sense?
Yes.
So the way I try to do this is represented in terms of these slots. The slot represents how many ways you can do it. So this is asking how many ways can I pick a president? And then this is asking how many ways can I pick a treasurer given a president was chosen. So if you tell me that there's 5 people here, there's 5 ways to pick the president. Is that correct?
Correct.
How many ways would there be to pick the treasurer, given the fact you already selected a president?
4.
4. Each time you picked one of these, there was 4 choices. Is that correct?
Yep.
Yes.
So the answer is 20.
Yep.
4 plus 4 plus 4 plus 4 plus 4 is 20. Does that make sense? Does
Yes.
that make sense, guys? 5 sets of 4,
Yes.
right?
Mm-hmm.
Because each time you pick the president, you're gonna have 4 choices for the other one. So it should be the number of presidents times 4. Is that correct?
Yes.
All right. So this is what we need to be able to do. I think listing it, I think you could figure that out. Does that make sense?
Mm-hmm.
Okay, so then in this case here, how could I count how many there would have to be? Well, let's go back to our beginning here. It says list the different ways that we could elect a president and a treasurer if the 2 officers must not be the same gender. All right, well, we can either go male, female, or we can go female, male. Is that right?
Correct.
The males, there's 3 males.
Mm-hmm.
The females, there's 2 of them. So there's 6 ways we can go male, female. Does that make sense?
Correct.
Female, male, there's 2 females, 3 males. There's 6 ways we can go female, male. 6 plus
Correct.
6 is 12. Same 12 here. Does that make sense?
Yes.
Jonathan?
I got it.
All right, so this is what we need to be able to do. This is what is gonna be the harder part for the exam. Does that make sense?
You're not including the other set that we did where it was the 20, right? It's just the 12.
Because they're only asking if so the other set where there was 20. Oh, this thing here, this was saying, this doesn't necessarily mean that it has to be 2 different genders. Is that correct?
Yeah. Okay,
Like A, B, we shouldn't be counting this because this is the same gender. Does that make sense? Does
okay. No, that's what I just wanted to double check that it's okay. I got it.
that make sense, guys?
Yes.
Yep.
Mhm.
All right, so again, we got the 5 members, assuming all members are eligible, but no one can hold more than 1 office. List a different number of ways they could elect a president, secretary, and a treasurer. If the president must be a man, and the 2 other must be a woman.
I thought we did that one.
No, this one's 3 now. We didn't do this.
Oh,
So there's El Presidente, secretary, and the treasurer, right?
yes.
Now it says the president has to be male. And these 2 people have to be female. Is that right?
Yes.
Okay. So how many choices we got for the male presidents?
3.
3 is correct. There's 3 ways to select that president. Is that correct?
Yes.
How many
Indeed.
ways is there to select the secretary?
2.
2, very good. Does that make sense?
Yeah.
Yes.
Yep.
How many ways is there to select the treasurer, given the fact we've already selected a president and a secretary?
1.
1, very good. Why is there only 1 way?
Because the position of secretary. is
That'd already be taken.
We already took 1 of the women. So if I took Cindy for secretary, Edith has to be the treasurer then. Is that correct?
Yes.
The only one option left. Yeah.
There's only 1 choice left, is correct. Does that make sense? So there would be
Mhm.
6 ways.
Yes,
That make sense?
indeed.
Yes.
All right, let's write them all out just because there's only 6 of them, because that doesn't bother me that much. All right, so I could have Anthony, Cindy, Edith. I could have Anthony, Edith, Cindy. I could have Ben, Cindy, Edith. I could have Ben, Edith, Cindy. I could have Douglas, Cindy, Edith. I could have Douglas, Edith, Cindy, and those would be all the ways. Does that make sense?
Mhm.
This was pretty easy to do because there wasn't that many of them. But if there was just a little bit more here, like it's really easy to make a mistake writing out this list. Does that make sense?
Yes.
Yeah, to be more combinations kind of thing.
Does it make sense though, guys?
Yeah,
You
yeah,
understand how
yeah.
to- you understand how to count it
Yes.
though?
Yes.
Because that's the harder part. Consider the club with 6 members: Alan, Bill, Kathy, David, Evelyn, Francis. Okay, whatever. List the different ways that the club could appoint a committee of 4 members when there are no restrictions to select a committee. Hint, a committee has no order, i.e. A, B, C, D is the same thing as A, B, C, D, C. Do you understand what he's saying here?
Right.
You understand why he's saying they're the same?
Yes.
Because there's no specifications.
Well, there's no, like, if I say Alan, Bill, Kathy, and David are on the committee, or I say Alan, Bill, David, and Kathy are on the committee,
On the committee either way.
still the same stupid committee. Does that make sense?
Yeah, it's not specific, but yeah.
Okay, so now the thing is like, we can't change the order anymore. Does that make sense?
Yes.
Yeah.
So now 4 members. All right, so we could get Alan, Bill, Kathy, and David, right?
Mm-hmm.
I could get Alan, Bill, Kathy, and Evelyn. I could get Alan, Bill, Kathy, and Francis. Is that right?
Yes.
Now I did everything where I have Alan, Bill, and Kathy. So now I can't have Alan, Bill, and Kathy, I guess, anymore. So now I get Alan, Bill, no Kathy. So now I guess we can have David and Evelyn. Then I can also have Alan, Bill, David, and Francis. Then I could have Alan, Bill, Evelyn, and Francis. Now I think I've done everything with Alan and Bill. Does that make sense?
Mm-hmm.
Yeah.
Now we could have Alan and we can't have Bill anymore. We need to have Kathy, right? So we could have Alan, Kathy, David, and Evelyn. I could have Alan, Kathy, David, and Francis. I could have Alan, Kathy, Evelyn, and Francis. Is that right?
Yes.
Correct.
Now I can't have Alan and Kathy anymore. So now I need David. So Alan and David and Evelyn and Francis, and I can't do anything else with that. Does that make sense?
Yes.
Yep.
Now who do I go to?
Now you got
Evelyn,
yes.
Who'd you say? Bill, who else?
Bill, Kathy, David, Evelyn.
Yep, now we gotta go to Bill. So Bill, Kathy, David, and Evelyn. Okay, so then we could go Bill, Kathy, David, and Francis, I guess, right? Then we can't pick Bill, Kathy, and David anymore. So now we gotta pick Bill, Kathy, and Evelyn and Francis. And then we're stuck again. Does that make sense?
Yep.
Yeah.
So then now we can't pick Bill and Kathy. Now we need to pick Bill and David. So Bill and David and Evelyn and Francis. Is that right?
Yep.
Does that make sense, guys?
Yep.
Mhm.
Correct.
Now where do I go?
Now you
Kathy.
gotta go with Kathy.
Now it's got to be Kathy, David, Evelyn, and Francis. And I think that's the last one we can do. Does that make sense?
Yes.
Yeah, the last of the group.
Yeah.
Now, if you want to think how we can count this, because we're going to have to talk about this anyway, then, because I don't know about you, but this was pretty easy for me to make mistakes. Does that make sense?
Yes.
Okay. So how can I count this? First, let's try and count it as if they weren't actually a group, that if they could just be rearranged, okay? And then after that, we'll think of a way to kind of change it, hopefully, all right?
Hmm.
All right, so how many people are there here? There's 6 people, is that right?
Yes. 60.
All right, so let's say first I was trying to count the number of arrangements.
Mm-hmm.
There's 4 things we need to arrange. there's 6 choices, then 5 choices, then 4 choices, then 3 choices. If we were arranging these things, there would be 30 times 12, 360 ways. Does that make sense?
Mhm.
Yep.
Let me just make sure I got the right number here so that I don't mess this up. 360 divided by 12, right? This one for 24. Should be 15. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, okay. So this is the correct amount. All right, so then now the thing is though, every single time, if I had picked, like, let's say I picked this green one here. The way I'm calculating it right now, this means I could reorder the C, D, the E, and the F. In other words, there's 4 times 3 times 2 times 1 ways that I could just rewrite this in terms of the C, D, Z, and Fs. Does that make sense?
Mhm.
You can't do that anymore, though. All of those is really just 1 way now, not 24 ways. Does that make sense? Same thing with this one. There would be 24 ways to redo this one. There would be 24 ways to redo this one. There would be 24 ways to redo this one. We got to take this whole thing and divide by 24. Then you'll end up getting 15. Does that make sense?
Mhm.
Where am I getting the 24 from? 4 times 3 is 12, times 2 is 24.
Okay, that's how you do it.
Okay, does that make sense?
Yep, writing that down right here.
I'll have a better way to say it with a formula soon, but that's the idea behind the formula.
Got you.
Does that make sense though, Jonathan?
It's because it's 4 positions in the committee, right? So it's 4, 3, 2, 1. That's why it's 4, 24, right?
If I pick 4 people, right,
Yep.
then I could have done like A, B, C, D. I could have said I'm going to put them on D, C, B, A. I could have done all these different ways. There's 24 ways that you could reorder them. Does that make sense?
Yes.
Okay, because you have 4 choices, then 3 choices, then 2 choices, then 1 choice. Is that right?
Yep.
So, but any of these would have done the same thing. There would have been 24 ways to do this one. There would have been 24 ways for this one, 24 ways for this one, 24 ways for this one, 24 ways for this one. So that means when I'm doing it this way here, I'm actually taking every single one of these and multiplying them by 24. And that's how I'm getting 360. So I got to divide out the 24. Does that make sense?
Yeah, I got that.
Okay.
Okay.
I'll have a slightly better way to say it. afterwards.
Okay, no worries.
It's the same thing, but that's the way to think about it. Does that make sense?
Yep.
All right. Anybody have any questions so far? All righty. Fundamental counting principles. So we already did this, so most of this should be pretty easy. In how many ways could members of the following club line up all 10 members for a photograph? N is equal to this thing. What would you say? There's 10 people. How many ways can I line them up?
10 different ones.
Way more than 10.
100 different ways.
Way more than 100.
You said it was
It's 1,000, I'm sorry. 10 times 10.
multiplied by 9, multiplied by 8, multiplied by, I don't know why, but that's the formula you showed us before.
You don't know why?
Well,
Yeah, because
No,
it's,
I don't know why. I saw what you did. I don't know why, but yes.
You should know why. We've said it a number of times. If I pick these people here, there's 10 people you can pick, right?
Yes.
How many would you have for the next one?
10.
Still 10, no?
Oh, yeah? You can line, wait, so you're saying there's 10 different people, and when I line them up, I can line Bob up twice? There's not 2 Bobs, right?
Okay, so it's 10 minus 1, 10 minus 9 minus 1, 8 minus 1, and so on, right?
Does that
Okay,
make sense?
so that is the reason. Let me just go back to my notes.
But that's what we just said before.
What we
That's
did.
exactly what I already said before. So the thing is that if we have this here, we even wrote them all out. There was 5 choices for this one. Then each time you picked one of these people, you already had selected them. There was only 4 remaining here. Is that right? That's why I'm doing 5 times 4. Is that correct?
Sometimes it takes time to click it in people's heads, including mine. So with the example that you gave us about the president and the secretary and the treasury, since we had 3 males, then we had 3 choices. And then when we had 2 females to choose from, so the first one we had 2 choices, and the second one we had only 1, right?
That was part of the parameters that was set in
You
the
talking about this
question.
one here? You talking about this one?
Yes, exactly.
Yeah, you have 3 choices for the males, then you pick, there's 2 women. So you'd have 2 people that you could pick for secretary, but no matter who you selected for secretary, that would automatically force someone to be treasurer.
Yes, so it's the same principle you're applying to the what we're talking about now, right?
Yep, every question.
Okay, thank you.
But I know it takes people more times to say these things, but the thing is Sarah, I still have to tell you that, that this, I have to relate this back to the previous thing, so you can see they're the same. Does that make sense?
Yes, absolutely. It just takes a minute to click in.
No,
It's
no, no. There's one thing I hate about math. It's that I will sit there and not understand and not understand and not understand and not understand. And then all of a sudden I understand. And then I look back and I'm like, what did I not understand at the beginning? And I can't tell you. You know what I mean?
yeah, I
And
completely.
it's just like, it just has to come from this way and this way and that way and this way and that way. And then finally I get it. And I don't know. It's really weird.
Yeah.
It's just the wording a lot of times.
The wording, yes, but it's not really the wording. It's really just not understanding what they're describing. Does that make sense?
It's not clicking in. It's like a maturing process. It's
Exactly. But it's just weird that
yes.
like you can ever understand. It's just weird. I don't know. It's just very strange. It's very frustrating. So the
Very.
anyway, in this one here, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Does this make sense now though? Of course, we would have to multiply this number out. To multiply this out, it would be this number, 3628800. If you multiply it out, does that make sense? You see what I mean? Also, like way more than 10, way more than 100. There's 3.6 million ways you could line these people up. Does that make sense?
Yes, but this is the case in which ABCD does not equal to the opposite of a DB something, right?
Correct. Correct.
The
If you were to rearrange it, this is a completely different rearrangement now, right?
Yeah. Mm-hmm.
So I like to use the words arrangements and groups. Are they asking me about arrangement or are they asking me about a group? And I like to separate the problems that way. Does that make sense? This is definitely an arrangement. We haven't gotten really to the whole grouping arrangement thing yet. All right. So let's just hold off on that a little bit. In how many ways can a male and a female be selected to decorate for a party from a club consisting of 8 members in which 5 are men and 3 are women? What would you say?
We would do the 5, 4, 3, 2, 1 for the men, and then the 3, 2, 1 for the women, and then you multiply the 2. No.
Much simpler than that.
It's supposed to be the 8 by 3.
Wait, what'd you say?
So it should be 8x5x3.
Nope.
Can't you do it like 5 and 1, 4 and 2, like that 5 and 1, 5 and 2, and 5 and 3? That way, like a tree?
Nope.
Oh, well, no.
How many people do we have to pick total?
8 members.
8 members.
Nope.
2.
That's not-
Two.
Two
It's
people.
the male and the female only.
It says you gotta pick a male and a female. It doesn't say anything about 8 people that you gotta pick. Is that correct?
Yes.
So how many slots should I write?
2.
2. So what do I put in here?
5
5
and
men,
3.
5 and 3.
Yeah. You have 5 choices here. You have 3 choices there. The answer is 15. Is that correct?
Yep.
Yes,
Does that make sense?
Yep.
yes.
That one
Mm.
wasn't it. All right. Counting numbers are to be formed using only digits 4, 9, 8, 2, and 6. Determine the number of possibilities for 2-digit numbers. All right. So if we got a 2-digit number, that means we got 2 slots. Is that correct?
Yes.
How many choices I got for the first one?
Four.
Nope. Where do you see
5.
4? There's 5 numbers, right?
Yeah.
Yes.
How many choices do you have for the second one?
2.
Nope. Where do
0.
you get 2? Where do you get 2 is 0? Where are you getting this stuff? Do you know what they mean by digits? Digits are the numbers. Digits are the numbers that go into the number. Does that make sense?
Right.
So they're saying
Okay.
like you make a number, you can make the number using these digits now. Okay. So we have 5 choices for this first position. Is that right?
Yes.
It could be a 4, 9, 8, 2, or 6. How many choices do we have for the second position?
4.
No. Couldn't you do 99 also? They didn't say I can't use the number twice. It's just 5 times 5.
This is why I'm getting through it, because it's 5 options, but where's the other 5?
Same numbers. The first one could be a 2, a 4, a 6, an 8, or a 9. The second one could also be a 2, a 4, a 6.
Right, okay, I see it now. Yeah.
Because it doesn't, they're not saying that you can only use the number once. Does that make sense?
Yeah.
Right? Like, I mean, you could have 22, you could have 24, you could have 26, you could have 28, you could have 29. Is that correct?
Yes.
Then you could have 42, 44, 46, 48, 49. Is that right? Does it make sense, guys?
Yep.
That one should have been easy. After we do it. All right. What about B? Now I think you should be able to do this one. Oh, even numbers? Whatever. All right, 2-digit even numbers?
It's 4.
4 for what?
4
For even numbers, you're saying?
Even numbers, yes.
5.
4 and
For even
4.
numbers. All right, let's start with that, okay? So if it has to be even, that means the second digit has to be even. Does that make sense?
Mm-hmm.
So that means we have 4 choices for the second one now. Is that correct?
Yes.
Oh,
Given the fact I picked the second one, how many choices do I have for the first one?
4.
4, very good. Why do you say 4, Dominique?
4 because there's 4 numbers to choose from.
There's 4 numbers left now. No matter which one of these I end up picking, there will be 4 left. Is that correct? Does that make sense, Teresa?
Yes.
Good though, Dominique. Determine the number of different possibilities for 3-digit odd numbers. Okay,
It's only one, it's 9.
so one more time.
It's only 9.
The last digit can only be a 9. Is that right?
Yes.
Good. So there's one choice for this one. Does that make sense?
Mm-hmm.
All right, how do I do the rest of this crap? Well, it ain't a 9 anymore. Is that right?
Correct.
So how many choices I got here?
For odd numbers, you don't have a choice.
No. Be careful. Be careful. Okay. So
Uh-huh.
like when you think of, so it's like 1, 1,
I
2,
get it.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like every one of them is odd except for the ones that are even. So evens have to end with the 2, 4, 6s, 8s, and 0s, right?
Uh-huh.
So we're saying the last one has to be a 9. Fine. The last one has to be a 9. These two could be anything. Is that correct?
Correct.
So there still are 4 choices remaining.
Right.
So I still could say 4 different things here. Then,
Right.
given the fact I selected something for this position and this position, there would only be 3 remaining. In other words, there's 12 different numbers.
Mm-hmm.
Does that make sense?
Yes.
Yeah.
Does this make sense, guys?
Mm-hmm.
Any questions so far? Teresa, question?
No, I was just rereading the question again. That's all. Because it was saying 3-digit odd numbers. So I'm still a little baffled because it's asking for 3-digit odd numbers. It didn't say anything about the even number. Uh-oh.
You didn't say anything about the even numbers. That's correct. All right, here, wait. Oh, how can I say this? 3-digit odd numbers. So 3-digit numbers are like 100, and then it goes all the way to 999. Is that correct?
Correct. Yes, that's
We
correct.
can't pick all these things though, because we only have like, what was it? 2, 4, 6, 8, and 9. Is that right?
Yes.
So like it would usually go 100, 101, 102, 103, 104, 105, 106, 107. The only ones that are evens though are the ones that have these things with them, right? In the units digits, right?
Mm-hmm.
So we can't put any of this stuff in the units digit. Does that make sense?
Yes.
Okay. So I'm just going to count the number of ways we can do it. So we have 3 digits. This one must be a 9. We have only one choice for this one. Does that make sense?
Okay, I see it now. Yeah.
This
it.
is like a 2-digit number now, and you have to make them out of these numbers. So you have 4 choices and 3 choices. Does that make sense?
Mm-hmm. Yes.
Multiple choice test consists of 8 questions, each with having 5 possible answers. And how many ways can the test be completed? What would you say? Try and think of how many slots we have. How many slots do we got?
8.
You have 8.
8 is correct. Because there's going to be 8 questions. Let's say you're guessing on all of them, right?
Mhm.
You have 8 different things you got to guess on. Is that correct?
Yes.
How many ways can you guess? Well,
8.
5. So it's
5.
5 times 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 5. So we get 5 to the power of 8. Does that make sense?
Yes.
I mean, if you just start writing it out, I think it's kind of easy to say, actually. I could pick A, B, C, D, or E for the first one. Then for the second one, I would be able to pick any of A, B, C, D, or E. Then for the third one, for the if I pick B the second time for the first one, I would be able to pick A, B, C, D, or E, and so on.
Yes,
Does that make sense?
yes.
Anybody have any question here? All right, for any counting number, the quantity factorial is defined as multiplying all the numbers down till 1. So n factorial is equal to n times n minus 1 times n minus 2 times blah, 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 times 2. The reason why they're saying this stuff is because he should be mentioning also n factorial means the number of ways to arrange n distinct items. Distinct, all I mean by that is distinguishable. All right? Like if I have 4 items, A, B, C, and D, the number of ways to arrange it is 4 times 3 times 2 times 1. So they call this 4 factorial. Does that make sense? If you have 6 things, then it's 6 times 5 times 4 times 3 times 2 times 1. This is called 6 factorial. Yes, this is 24. Yes, this is 720, but people start writing it like this because they don't want to write it all out. And it's faster. Does that make sense?
Yep.
Does that make sense, Teresa?
Yes.
So he says examples. 4 factorial. Okay. Oh, so he says 0 factorial is 1. That actually makes sense also in terms of what I'm saying here. So like 0 factorial is equal to 1 because there is one way to arrange 0 things. You just don't do anything. Does that make sense? Like I am sitting in a classroom right now and there are all these desks here and there's not a single student in here. All right. And how many ways are there for these students to sit in these desks? One way. Nobody sits down. Does that make sense?
Yeah.
Okay. So there's still always like a way. All right. Okay. So 4 factorial really just means 4 times 3 times 2 times 1. So that's 4 times 3 is 12 times 2 is 24. All right, this one, the reason why they're showing you this is because this is the way we end up calculating a lot of these different problems. So in this one, this would be 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18 times all the way down until 1. And this would be 20 times 19 times 18 times 17 times all the way down until 1. Does that make sense?
Yes.
What could you do here to figure this out?
Simplify it.
You can cancel. 20 cancels with 20, 19 cancel with 19, 18 cancel with 18, 17, 16, 15, 15, 30, all the way to 1, they all cancel also. Is that correct?
Yes.
All right.
So this is just going to be 25 times 24 times 23 times 22 times 21. And that's all you need to do on your calculator. 25 times 24 times 23 times 22 times 21 is that number. 6375600. Does that make sense? The point
Yes.
why I'm showing you this though is because this is how you're supposed to calculate. People sit there and do all these things in their calculator and they make all these mistakes. You're supposed to just write it out and cancel, and then use your calculator. Does that make sense?
Yeah.
Yes.
All right. So this one should really be the same thing as saying you got to always do what's inside the parentheses first. So this is 5 factorial over 3 factorial. Does that make sense?
Yeah.
Yes.
All right. Now, always what's going to happen is there's going to be a bunch of crap that cancels. So you look at the thing on the bottom and you start saying it's gonna be like 3 times 2 times 1. Well, another way to write 5 factorial is 5 times 4 times 3 times 2 times 1. But I could also write it as 5 times 4 times 3 factorial. Does that make sense?
Mhm.
Why would I do it like that? Because then it's a little easier for me to see what I'm canceling. Because then
Oh,
this
yeah.
and this would cancel here, and we just get 5 times 4, so we just get 20. Does that make sense?
Yeah.
Yes.
All right. So this one should be 9 factorial over 7 factorial, 2 factorial. Is that correct?
Yes.
Somebody tell me how they would write this out to cancel stuff.
9 times 7 factorial
Not,
and
don't forget the 8. You can't forget the 8. Does that make sense? Like 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Is that right?
yes.
Where should I stop this?
7 factorial.
Yeah, we might as well just leave it like this. So I can cancel the 7s. Does that make sense?
Yeah.
Yes.
But then
You actually
you gotta still write the 2 times 1 out. Does that make sense?
Yeah.
Mhm.
So you
actually
stop.
cancel the 7s.
We're gonna cancel the 7s, definitely.
What about the parentheses?
No, that's 9 minus 7, that's 2. So that's this part.
It doesn't like explain it or anything, right? It's just like it's 5 minus 2, that's it. Or 9 minus 7.
Well, the order of operations says that you always have to do parentheses,
First.
exponents, then
Exactly,
multiplication,
that's why.
division from left to right, then addition and subtraction from left to right. So I have to do what's inside the parentheses first. I have to simplify that. That's 2. Does that make sense?
Okay, just wanted to make sure.
But after that, then what?
Say one more
So I'm
time.
wondering if the 7s is gonna be there.
All right, I'm gonna write the whole thing out. So this is gonna be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then 7 means 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 means 2 times 1. Does that make sense?
Right?
Right? Now I'm gonna cancel these here with here, right?
Yep.
All I'm saying is I can also do it like this. It's the same thing.
Okay, I see it now.
All right, now, the only thing is we still got more stuff we gotta cancel. 2 has to cancel with the 8, we get 4. Is that right? 2 goes into 8 4 times. Is that correct?
Right.
Yes.
9 times 4 is
36.
36. So that's what they want us to do. Does that make sense?
Yep.
All right, n factorial. So now this means 26 factorial. God, why do they pick such big numbers? K is 21 factorial. What's n minus k factorial? What do I write over here?
Oh, 26 minus, oh,
Yes, sir.
5.
I have a question
5
for
factorial.
an 8.
Yes, Dominique?
I'm trying to figure out why you did 8 times 2 instead of 9 times 8.
Oh, okay. So we have 9 times 8 over 2. Is that correct,
Mhm.
Dominique?
Yes.
All right. Now, this one question honestly tells me if someone explained to you fractions correctly or not. This one question, okay?
Okay.
Because what the only thing that I can say at the end of the day why fractions are good is because you can cancel, because you can make the number smaller and then it ends up being less stuff to do. All right. So there's 2 ways you could do this question. One way is you could say that this is going to be 9 times 8 is 72, and then we have to divide that by 2. We would get 36. Is that correct?
Yeah.
I get it now.
That's not the good way to do it, though.
I
That's
know
bad.
that I know. So like when you wrote it out like that, then I recognized it.
Okay.
Just the
So
way
the
that I,
only thing we gotta do is you always just try and cancel and make the stupid number smaller. So like 2 goes into 8 4 times. So we just make it smaller. So then 9 times 4 is simpler, same 36 though. Just makes it easier for me to do in my head, honestly. That's all it really does. And I make less mistakes when the numbers are smaller. Okay.
okay.
So all I'm just saying is don't forget to cancel. All right. So, and the reason why I say this is I don't think people explain that the reason why we're doing this is to make the numbers simpler. That's the only reason. And that is a good reason to do things. Does that make sense? All right.
Yes.
So 26 factorial over 21 factorial 5 factorial. So this should be what? 26 times 25 times 24. Where should I stop writing this thing?
21.
21, good. 24, 23, 22, and then we leave the 21. Why do I leave the 21? Because I'm just gonna cancel that shit. Because otherwise I have to write out 21 numbers and I don't wanna do that bullshit. 5 times 4 times 3 times 2 times 1. I'll write those out instead. Does that make sense?
Yeah.
Yes.
All right, so then these are gone. Is that correct?
Yes, it is.
Yep.
Now just start seeing if you can start canceling anything with anything. It doesn't really matter which ones you cancel, just cancel something. So I don't know. I see 2 goes into 22. Does that make sense?
Yes.
So I'm like, all right, 11. Does everybody see that?
Yeah.
Yes.
What else does anybody see here?
5 and
4 goes
24.
into 24.
4 goes into 24. How many times?
6.
6.
6 is correct. What
5
was
and
someone else saying? 5?
3 and the 24.
3
into
into 24 is correct, but the only thing is I already canceled the 24 here. So now I'm gonna say 3 goes into 6. Is that right?
Mm-hmm.
Yes.
All right. You can't do 24 again. It's already gone. So then this 3 goes into 6 twice. Is that right?
Yes.
What else are we gonna cancel?
5 into
25?
25.
5 goes into 25.
5 times.
5. So then we would have 26 times 5 times 2 times 23 times 11. Does that make sense?
Yeah.
Yep.
And believe it or not, you could probably do this in your head. This is 10, this is 11, that's 110. And then we really could do this, but I wouldn't. I would just do this on my calculator now. Does that make sense?
Yeah.
Yeah.
So this is going to equal to something. 26 times 5 times duper times 23 times 11, 65, 780. Whatever that is. Does that make sense?
Yes.
All right, we're going to stop here. We'll do this next time. Okay.
Okay.
Anybody have any questions about anything?
What was the answer to our last problem?
65,780.
65,780. So that is something.
You want me to just check it real quick? Let me just check it real quick. Make sure it's right. What is this? 26.
I got something else.
26. Choose 5. 65, 780. That's right. Question?
I sent you an email last Thursday. I didn't get a reply yet.
Sent me an email last night.
No, last Thursday.
Let me check 1 second.
I mean, it's like personal. I just wanted to make sure you got it. I didn't get a reply.
I didn't get an email from you. No.
Let me
Where'd
double
you send it?
D2L.
Oh, I don't respond to emails on D2L, but I didn't get it on D2L either.
Let me double.
Because I would have just found it. Let me just look, see if I can,
Is Outlook email a better way to reach you?
any email, just, oh, you did, it's here. Class today. Weird. Why
Okay,
didn't I
yeah,
get-
it's personal though. I just wanted to make sure. That
I'm
you
not gonna
got it.
open it. I'm not gonna open it now. It's just, the
Okay.
thing is, why didn't I get on my phone? Oh, okay. I did respond.
I never got it.
Okay, that's the reason. The reason why is because you sent it on D2L.
Okay.
If you send something on D2L, I can't tell. I'll respond on my phone and I can't tell that you didn't get it. Does that make sense?
Right.
So that's the problem. That's why I don't want people sending things on D2L, because otherwise when I respond to people, they don't even get my response.
Okay.
All right,
Gotta figure something out. All right.
all right. So just anytime you want to email me, just email me at,
The Outlook one.
yeah. Well, you can use it from, you can email me with any email address you want. I don't care. This is the email. Does everybody see that?
Yeah.
Okay, it's just
Oh,
the thing is that if you send it from D2L, unless I go log into D2L and click this thing here, you're not gonna get my response. So the problem is that I try to respond almost immediately, and then when I do, you're not getting it. And I don't know you
Yeah.
didn't get it. Does that make sense? Because the problem is when the email comes in, unless I go check the email address and I see that it says at BC Online,
Right.
I don't know. So and I don't check every single email address. I just respond to the email. Does that make sense?
Yeah, no, I understand. I understand
So
what's
that's,
happening.
I apologize about that, but try not, don't email me through D2L. Does that make sense?
Yeah.
Just use any email you want and send me the email to this email address. Just identify your class you're in. If you want, if you have a question on a math problem, take a picture of the problem, take a picture of your work, send me those two things. Does that make sense?
Yeah.
All right. Thanks.
Sorry about that, Tums. Anybody else have any other questions?
No.
I have a
All right.
question, but not regarding like the math, just regarding the class,
What's the question?
like the recording, because I came in late today. And I want
No,
to know,
I'm not gonna post the recording.
is there any way that I could get the recording for like the first half of the class?
No, people have to come to class.
Ye-
All right.
No, I got that.
Okay, I apologize, but people are taking way too much advantage of this. There was like something like 6 or 7 people in here, and then only 1 or 2 of them was really responding to me or whatever. I can't run class that way. I can't sit here for 3 hours doing this.
No, I respect that. I was
No,
just
it's not, I don't like saying this. Like I don't actually like this is happening. Because I want to be able to give people the videos. But the problem
Yeah.
is that I feel like there's gonna be more people that end up failing the class if I do that. Does that make sense?
I know I got that. I just like going over them and like seeing things that I didn't miss.
No,
Like-
that I completely understand. What I will remind you is that if you go to course notes here,
Yeah, the notes are there.
and all the notes will be there. So everything I write will really be there. If you have any trouble with any of the parts, just contact me and then I'll meet with you and I'll explain it to you.
Okay. And also I had another question in regards to the assignment, the Morgan's laws, the the assessment. Where do I find that?
Find what?
It says assessments, like there's a little thing in the grade book. But I don't know because it's very complicated. Some things you don't count. Like towards the
The
grade.
grade, well, so don't worry about what's in the grade book. Only worry about the things that I'm telling you that I'm counting. Does that make sense?
Yeah,
So
'cause you never mention
the
it, but
only
then
thing you have to
someone
worry
mentioned
about is the stuff that's on the
everything
assignments.
there. Okay, perfect. Thank you.
Right? I'm gonna go clean up the whole grade book afterwards, but effectively, like they made people do more assignments in here that I thought were unnecessary. So I'm just
Yeah.
not assigning them to you. Does that make sense?
Yeah, it does. It does.
All right, and I think that just makes it easier for you. That's the only thing I'm really doing. All right. I feel like they're just wasting people's time telling them to do more busy work. And I was just like, there's no point. Does that make sense?
You're right. Yeah.
Yeah.
Okay, so that's all that was. I didn't delete all the crap that they had in D2L yet. I will though. Like the grade book, I'm gonna end up deleting I'm gonna redo the whole grade book.
Okay.
Okay.
And the previous recordings, are the previous recordings there? Or
Those
did
are
you-
still gonna be there. I'm not gonna
Okay.
remove those.
Perfect.
you.
Thank you so much.
All right. I apologize about this. I really don't like doing this. All right.
No,
But-
it's fine. I understand.
It's just almost impossible to sit here and do this class for 3 hours and then people not participating. Does that make sense?
Of
Yeah.
course.
All right. Also, like, if people go home, even if they are watching the videos, which I'm glad people actually are, but it just takes people a lot longer to do it when we're not in class. So if we do it together, you'd be surprised. You actually do it. You'd actually be able to finish faster. All right.
Yeah. Agreed. All right.
All right. Anybody else have any questions?
Nope.
All right. And I'm serious about the other thing where you send me an email. If you're confused with any of this stuff, I'll still help you with it. All right.
All right,
Thank you.
Okay. But the only thing is that if you're not attending the class and then you're asking me, like, I'm not going to sit there and go reteach the whole thing. Does that make sense?
Yeah.
Yeah.
Okay. But you got a question about a question, you got a question about one minor part that you didn't understand, you got a little confusion in one of the problems and you didn't understand how they wrote the answer out and they wrote it this way, why they do that, anything like that, you can always ask me and there's no problem with any of those things. Okay. It's just if someone turns around to me and tells me, hey, I don't understand this entire section, I need you to redo the whole thing with me, I'm not going to do that. Does that make sense? Then I'm going to say to you, you probably should go to tutoring first.
Yeah.
Right? Because don't forget, you do have free tutoring, right?
Yeah.
Right. So, and because you're doing an online class, you have even more free tutoring than the other kids do. So the other students, all right. So so don't forget that also. Okay.
Thanks, Professor.
Thank you.
Have a good evening, everybody. Unless
Night.
anybody has a question.
Good night.
Bye. Thank you so much.
Good night.
Have a good evening.
Thank you.
Shambria, did you have a question?
No, I didn't, Professor.
Just making sure. Everybody else okay?
Actually, I have a question, Professor. I was wondering the test that we're taking. I usually wait to try to give myself more time to study because I struggle a lot with math. So, I was wondering the homework assignments because I know you told us to only do the homework assignments and the test. Is it possible to open up the ones from before so I can try to get more points on them?
What, reopen the homework assignments?
Yeah.
That I cannot do.
Oh man.
Because when it's an online class, I'm not supposed to really open anything again.
Oh, I see. Okay. That's what I was.
What I will do is this, keep doing your work, okay?
Okay.
And then at the end of the semester,
Mm-hmm.
I'll look at it all together again.
Okay.
If it's gonna make a difference, I'll go and reassign you the assignments at that point, and then I'll ask you to do it then.
Okay, because I got better with the homework, but I mean, I'm
Because
trying to.
because the reason why I say this is if you do well, just a little better on the tests, because you're doing the homework close to when you take the test, then
Mhm.
your grade will go up a lot from that. Does that make sense?
Yeah, it
The
does.
homework doesn't change your grade that much,
Oh, okay, I see.
and some of them get dropped also. So I'd rather you don't go back and start doing stuff from before. I'd rather you focus on the test you have now. Does that make sense?
Yeah, that does. Because the
And
first test,
then we
did.
can worry about the grade at the end, if there's a problem.
yeah, because the first test.
Because if you show me you're going like this with your grades,
Hmm.
like that's what I need to see. Does that make sense?
Yeah, it does.
If your grades are going like that, then there's nothing I can do. But if your grades are going like this,
Okay.
there's stuff we can do at the end. Does that make sense?
Yeah, I'm getting it slowly. I'm working on it.
Well, you did, there was one question today that was pretty good, that you had that answer, so that was pretty good. All right,
Thanks.
all
right.
right, then. Just let me know if you have any trouble, all right?
I will. If anything, if I have a question or something, I'll just send it to your email.
That's fine.
Thank you.
All right, have a good evening.
You too.